Okay, I'm gonna turn the lights off. Okay.
Don't be slow.
So you put it in standard form. You set it equal to 0.
You're not right.
A is 1, B. Sorry, A is 1, B is -4, C is 9. Right? Did the formula opposite of B? Plus or minus square root of B squared, -4, minus 4AC. A is 1, C is 9, right? All of it over 2 times 1. Okay, you did it. You got what here? -4 times -4.
16.
16. What's a negative? Times a positive. Times a positive.
-30.
Negative.
-36.
4 times this is 36. You end up with what?
-20.
4 plus or minus square root of -20 over 2. Okay. So now what are you going to do?
Not.
What?
There's no solution because you can't find the square root of a negative number.
Can't find the square root of a negative number. Is he right? Because, look. Square root of 9, everybody knows square root of 9 is
3.
3. How come?
3 times 3 is 9.
Because 3 times 3 is 9. Or -3, because -3 times -3 is 9, right? But if I go like this to you, do you know how many students will say the answer is -3? Tons of students. When I say tons, I don't mean tons. I mean like just a few. A few will say -3 because -3 times -3 seems like it should be -9, but it isn't. It's what?
9.
It's positive 9. So this doesn't work. Does 3 work?
No.
3 times 3 is 9. No. So nothing works. You can't take the square root of negative numbers. Okay, let's go back. So you will say, kind of what Brady said, there are what for an answer?
No solution.
There is no solution, but here's the deal. We use this word. No real solution.
Because there's an imaginary solution. Don't even
Oh,
say
you
that.
shouldn't have given it away, Ethan. Don't let those guys know.
Just smack them.
Yeah, smack him. Here's the deal. Ethan let the cat out of the bag. He said there are answers. They're what, Ethan?
Imaginary.
You weren't supposed to say it, Ethan.
Oh, you just said there.
I know. But there are answers. They're imaginary answers. Guess what? That's chapter 5. That's next. As of today, there are no answers to radicals that have negative numbers inside. So you just say no real answers. No real solutions. Okay. Continue. Okay, go do 3B. Or if you're done, do 3C. What was the solution to 3B, Bryce?
The solution.
Yeah, what was the answer? No clue. Okay. Amber, what was the answer
For what?
for 3B?
X equals -4 plus or minus the square root of 16 minus 16 all over 2.
Okay.
So,
But you never got,
There's 2.
X equals -2.
so x equals -2. So you're saying -2 is the answer? What about the other one?
There's another one.
There is no other one. She says -2 is the only answer. Let's see if she's right. Here we go. 4 times 4 is
16.
16. Negative times positive is negative. And 4 times 4 is 16. So you're getting -4 plus or minus square root of what?
0.
0 over 2. Does the 0 make you smile?
Yeah.
It should, because it's perfect. What's the square root of 0?
0.
So really, this just says, right? And negative 4 plus 0 is negative 4, and negative 4 minus 0 is negative 4. So the top number doesn't change. It's always negative 4 over 2. Amber said the answer is negative 2, right? So here's the deal. Look at the first one. No answers. No real answers. Look at the second one. How many answers did you get?
1.
Just one. One solution to this one. Isn't that weird that it didn't seem like yesterday we always got 2? Yesterday we always got 2. Today we're getting none and 1. And now do that. Are you already done?
Getting there.
Getting there. Okay, not quite. Okay.
Not that fast.
First put it in standard form or else you can't go anywhere. Worked it out, and got what, Jessica?
4 plus or minus 2 times the square root of 14 over 2.
Okay, 4 plus or minus, what was the number in front of your square root of 14?
2.
2. 4 plus or minus 2 square root of 14 over
2.
2. You got a 4 and a 2 and a 2. Could we have reduced that? Yeah, she's got it, I think. She just doesn't have it reduced. Okay, so let's just continue and see if we can get her answer. On the bottom there's a 2, on the top there's a 4, and here comes the tricky part. Inside, what's this? 16. What's a negative times a negative? 4 times, skip it. 4 times 10 is?
40.
40. 40 plus 16.
56.
Okay. Now if you remember, Jessica said square root of 14, but that's because she simplified. 56. What's the perfect square that goes into 56? 4 times 14 is what she did, right, Jessica? Okay, square root of 4 is what? 2. 4 plus or minus 2 square root of 14 over what? 2. Okay. Now, this is the only thing I said to Jessica is 2, 2, and 4. What goes into all of them? 2 does. 2 goes here. 2 goes here. Once, don't write it. Square root of 14 over 1. Don't need what? I don't need the 1. You want to put it, but you don't need it. So, there's your 2 answers. Whoops. Plus or minus square root of 14. 2 answers are right here. 2 plus square root of 14. What else? 2 minus square root of 14. There you go. Got him. You fine? Okay. Now, the first one had no answers. The second one had 1 answer. The third one had what? 2 answers, right? Isn't that what happened?
Yep.
Now, everybody, look at the question on the bottom. Look at the question on the very bottom. It says, how are the solutions for the quadratic equation related to the graph of that equation? Come on over. Take a look. I graphed A, I graphed B for you, and I graphed C for you. Look at the 3 graphs of ABC. Then look at the solutions. Tell me something you recognize about the solutions compared to the graphs.
The solutions, if there's one one x-intercept.
If there's one solution, then there's one x-intercept. Good.
There's two.
If there's two solutions, there's two x-intercepts.
There's none, then there's none.
And if there's no solutions, the parabola never touches the x-axis, right? So what do we want to say about that question? How are the solutions related to the graphs?
How many solutions? There.
Kind of, yep.
Crosses the x-axis.
So to me, the solutions of the quadratic equation are really just what?
X-intercepts,
The x-intercepts. Do you want to write that?
kind of.
I would. The solutions to the quadratic equation are really just the x-intercepts on the graph. That's all they are. And you know what? You guys should have known that. Because, wasn't it last week I gave you a graphing calculator? And you found the x-intercepts and you called them what? Solutions. Well, today I'm saying solutions are just x-intercepts. So I'm going the other way. Big deal. Right? Okay. Now, before I go to the next page of your notes, I just want to ask you this. How will you know? How will you know when there's one solution, two solutions, or no solutions?
Positive.
There's a way. Did you figure it out?
You could just do the what's inside the square root.
What's
Like the
inside
base-
the square root?
B squared minus 4ac.
Okay, so Brady's just saying this. If all I ask you is this, how many solutions? 1, 2, or none? Brady's telling you, take the b squared minus 4ac. Right? Is that what you're saying?
Yeah.
And if this is what?
If it's positive, it has two solutions. If it's zero, it has one. And if it has, if it's a negative, it has no real solutions.
Okay, so he says basically, he put it together what we just did. If the number inside the radical is negative, you say what?
No real.
No real solutions, right? If it's zero, what?
One.
One solution. Okay, if it's positive, it's two solutions, right? That's all it was. So if this number is negative 10, what will you say? How many solutions?
0.
No solutions. What if this number was positive 10? Positive.
2.
Two solutions. What if this number is 0 in here?
1.
One solution. That's what you're doing today. That's all you're doing. And this number inside, b squared minus 4ac, is given a name. If you turn your notes, one more page, I think. There's a name for it. What's it called? It's called the discriminant. Okay, now, the discriminant, to make it easy, I just go capital D. Capital D is the discriminant. Really, all it is this number. Whatever b squared minus 4ac is, that's the discriminant. That's all it is. So now when I look at your notes, over here,
Then the what solution?
it's what now?
I was talking to myself, my bad.
It's okay. Talk to myself a lot.
Yeah, that happens when you're
I cannot find it. Nope. Let's do this one. There it is. Is this it?
That
Okay.
happens when you're slow.
Look inside. Here's the quadratic formula. That is not what I'm pushing today. I'm not pushing that today. I'm pushing this right in here. This, b squared minus 4ac, is called the discriminant. So I'll go like this. For some reason, people think the discriminant still has the square root on it. It doesn't. It's just the number inside, and that is it. The discriminant will tell you the number of
Solutions.
real solutions. How many real solutions does it have? The reason we're saying real is because there's imaginary solutions. They come in chapter 5. Okay? If b squared minus 4ac is greater than 0, and when I say greater than 0, I'm talking positive. Sometimes it seems like if they just say it, that's what it means. If b squared minus 4ac is positive, the equation has two real solutions, right? If the discriminant is equal to 0, there's
1.
one real solution. If the discriminant is less than 0, so in other words, what?
Negative.
Negative. You'll say
No real solution.
no real solutions. Good? So today, guys, I'm not asking you to do the quadratic formula unless it says, what are the solutions? If it says, what are the solutions, then use the formula. If it says, how many solutions, right here, determine the number of real solutions, that's just saying 1, 2, or none. Okay, here we go. Let's do it. We got 3 problems. Evaluate the discriminant, so find the number, then determine if it's 1, 2, or none for solutions. So, sorry, this is messed up. 9x squared plus 6x plus 1. Okay, what's the discriminant? We should know. It's just the number inside the radical, right? That's all it is. Go ahead, punch it in. No, I didn't mean to say that, sorry. I don't mean punch it in, I mean work it out. Work it out.
So we use a different formula now for this stuff.
Well, it's not a different formula, it's just the number inside the radical. It's a piece of the formula. And the piece is called the discriminant.
Oh man. 0.
Strip it up.
You will get a point on the test if you get the number right. You will get another point on the test if you say the correct thing, 1 solution, 2 solutions, or no solutions. So what did this all work out to, Jessica? Gillian?
Okay,
What'd you get?
0.
She got 0, is she right?
Yeah.
Yeah? Okay. 6 times 6. 36. Negative times positive times positive. Negative 4 times 9. 36. She's getting a discriminant of 0. That's 1 point on the test. Now you gotta say what it means. There's 1 solution. That's all it means. Now, if I asked you to go find that solution, how would you find it? Quadratic formula. I'm not asking you to find it. I'm just saying how many. Just 1. Okay, do the next one, and then do the next one, and we'll pump these out pretty quick. Remember, put it in standard form first, then work out the discriminant. Negative times negative.
Positive.
Positive. 4 times 9 times 4 is?
144.
1 what?
I got 144.
144. Final answer? Discriminant 180, which is positive. All you care about is positive, negative, or 0. That's positive. What are you going to say? 2 solutions. That's all you got to say. I don't care what they are, I just want to know how many there are. You know what I forgot to say? Forgot to say this word. Real. 2 reals and 1 real, okay? Okay, 9x squared, right? Plus 6x. Then what? Plus 5. Move the 5 over. 0. Go get the discriminant. D equals 6 again. A is 9. C is 5. 36. Negative times positive is negative, right? What's all that?
180.
That's 180.
Yep.
Okay, 36 take away 180 is negative.
144.
Okay, the discriminant is that which tells you to say what?
That's no real solutions.
Right? So is the discriminant easier than the quadratic formula?
Yeah.
Yeah, it is. All it is just do the inside, what's inside the radical, say 2, 1, 2, or none for answers. And if I said, what are the answers? Then you'd have to go back and do this whole mess all over again. But that was yesterday. All right, read the story problem, get an idea, even draw yourself a picture. I would. I like pictures. I like to see what's going on.
Something looks familiar.
You hit a golf ball into the air from a height of 1 inch above the ground. Why 1 inch?
On the tee.
It's on the tee.
It's on the tee. Okay. So to me, I'm going to go like this. I'm going to go up. There's the tee. There's the ball. You hit the ball. Probably lands on the ground over there, right? Okay. It says with an initial velocity of 85 feet per second. Guys, that means so little to you. It just means how fast you hit the ball. It's usually in the formula somewhere. Don't even worry about it. It's just part of the formula. All right, the function h for height of the ball equals negative 16t squared plus 85t plus 1/12. Models the height in feet. So height is measured in feet of the ball at time t measured in seconds. So here's the deal. The x-axis is now the what axis? What took x's spot? Time, t. T for time. Measured in what?
Seconds.
Seconds. Okay. Now what took the y spot?
Height.
Height. The height of the golf ball, right? Okay, now listen to the question. It says, will the ball reach a height of 120 feet? Will it? Probably. Is that what someone said? If I just knew where 120 was, I could tell you yes or no. I don't know. Tell me where 120 could be. Where could 120 be? Vertex. Okay. Somebody said it's a vertex. Right here. So you say it could be there, right?
Mm-hmm.
But where else could it be?
In the middle.
I'll put a question mark there. In the middle, right here?
Or above.
Okay, you saying 120 could be here? Question mark. Or above, I heard you say. Gotcha. Guess what? It could be anywhere, right? It could be the vertex, it could be below the vertex, it could be above the vertex. How would you ever know if the ball can get to 120?
Put 120 in for H.
Put 120 in for H. Then what?
I don't know.
Subtract it and get it on the other side. Okay.
Then you do the whatever it's called.
Well, guys, here's the deal. Listen. The deal is, if 120 is here, just watch this so closely. If 120 is here, tell me, did the ball ever reach this height? Not just once, but twice. What would the discriminant be if there's two solutions? The discriminant would be positive. But wait a minute. What if the 120 was here?
And one.
Just one solution. What would the discriminant be? 0. Right? What if 120 is up here?
Will be
There's no solution.
negative.
So then the discriminant would be what? Negative. So guys, when you read the word, will the ball, it's a question. Will the ball reach that height? It's a discriminant problem. So go find the discriminant. You want to know if the ball ever reaches what?
120.
120. Well, I think, Cassie, you said it, didn't you? Somebody said put 120 in for H. You said it, Carr, my fault.
Boy.
Okay.
That's right.
So you guys, go find the discriminant. Go. I'll wait for you. When you put it in standard form, you got 0 on this side. What did you get over there when you subtracted 120?
Negative
Negative.
119 and 1112.
Oh yeah. Yeah, not a really nice C value, right? That's really not a nice C value, but here's the deal. You guys all have calculators, it's not gonna hurt you. All you gotta do is a discriminant. Those are some ugly, ugly numbers. Thank goodness for calculators. Discriminant is equal to. Somebody told me this was 7,000 something. 225? Okay. Negative times negative times negative is negative? I'll wait for you. You tell me what it is. I know 4 times 16, that's 64. 64 times negative 119. Something. Help me, help me.
I got 7,674.6.
Wait, 7,600 what?
74.
Point
6 repeating.
6 repeating. Okay. I don't know if that's right.
It's
Can you
not.
guys double up? Can anybody say that? Is that it? Yeah? So, what's this minus this?
There you go.
For sure it's negative. I don't know. 400 something. 400 what?
449.6.
49.6. Okay. Oh, okay. Discriminant's negative. What's it telling you? Where's the 120? Way up here in the ball, yes or no? No! Guys, you want to say what? No! And then you want to say because. Because why? The discriminant. What are you going to say?
It's negative.
There you go. The discriminant is negative. Which tells me what? The ball
Doesn't reach 120.
will never reach 120. Okay? And how do I know it will never reach 120? Because if the discriminant's negative, there's no answers. It will never reach 120. Now what if the discriminant was 0?
That'd be one solution.
Then it did reach 120. How many times? This one, it was at the vertex. If it was positive, you'd say,
Twice.
yes, it reaches 120. Twice. One's up, and one's down, it reaches 120. See what I'm saying? This is nothing more than a discriminant problem. Will the ball reach this number? So when you read it in the book, guys, and it says, will the ball ever reach 60 feet? You think discriminant. Well, tell me. You don't have to tell me when. Just, is it a yes or no? Yeah, it's yes or no. Just use the discriminant to help you answer yes or no. Brady.
What if it's like Tiger Woods and he
Okay.
just bombs it?
Okay.
I think it would go like over like 400.
I just ordered
Yeah, okay, but listen.
more happy.
it. Yeah,
Here's the deal.
happy I'm
If you want to hit for distance, do you hit the ball like this? No.
Well,
Distance
Tiger
is
Woods.
you want to hit the ball like this, don't you? Isn't this really how a golf ball goes for Tiger Woods? Probably goes. You know what I mean? Those shots are like low and they
It
reach
gets
up.
caught by the wind.
Boom. That's really what they look like. They're not perfect. They're not perfect parabolas. Or are they? No, if you guys golf, if anybody golfs in here, typically a nice shot starts like this, takes off, reaches its height, and then what? Comes down fast.
But if you're using a pack wedge,
Now wait a minute, I said a driver.
Oh.
If you're using a wedge or sand wedge, what do they call sand wedges?
Well, if it's just a pig,
Then they go what?
Bombs.
Then they go,
And it doesn't go over
and
too.
then it's a parabola.
That would be a parabola.
Probably a wedge shot is a parabola.
No, I mean like if it's just some pig and he just bombs it, but like it doesn't go like 2-3 feet off the ground. Would that be a parabola? It would
Yeah,
just be like
if
a
you
straight
just-
line practically, but it would,
But if it goes
it
like
would just
that,
be super compressed.
that's a parabola, right? But you know, Tiger Woods will hit it like this,
Yeah, because he's a bomb.
and then it just kind of falls quick.
That's a good idea.
I assume it was on that thing.
Okay,
Yeah.
you have whatever. You have a day 2 assignment. This is day 3 tomorrow. So tomorrow it's a lot of.
On the ball.
I don't have to talk much tomorrow, guys. You know most of your stuff, okay?
Okay, I just traded.
What work?
am I
No, it's Jim with the Stone Cold Stunner. That's how
Oh yeah,
What's it, what's this called?
the Stone Cold Stunner.
You don't.
Stone Cold.
Stunner.
You get that same stuff. What do you have? Well, then-
You used to.
I could,
No, I'm trying to tell you now. You don't even have to.
Cold Stone Creamery.
Whatever.
Stone
Stone Cold Cedar.
I'm smarter than
I could beat him.
Could you really?
He's got the muscle on his spine.
Who?
He's jacked.
I bet you beat him with a regular fire. I did it.
Day 4 was a 1, 2, 3.
Wrangler. And just person for Wrangler.
Noah, can you get the lights?
Thanks.